Hey everyone, and welcome to another deep dive. Today we're going to be tackling the world of generative AI. You know, those tools that can write poems, create art, even code. We're using a really interesting article as our guide. It's called Sen Autant Ace. And the big question here is, has this amazing tech hit a wall?
It's a valid question. There was so much hype initially with tech giants investing billions based on the idea that bigger AI models would just equal better performance.
Yeah, it was a race to build the ultimate AI brain.
Right.
But now there's this concern emerging that simply scaling up might not lead to those same breakthroughs we saw before.
Exactly. Even within OpenAI, the creators of ChatGPT. Some are skeptical about whether this bigger is better approach will keep delivering those mind-blowing leaps forward. Some reports suggest their next model, Orion, might not be the game changer that GPT-4 was compared to GPT-3, and that's significant considering the billions of dollars and the potential applications.
Okay, so why are these giant AI models potentially hitting a wall? What are the limitations?
Well, one major factor is the resources these models demand. We're talking massive computing power, which means huge energy consumption and sky-high costs.
So not just a financial hurdle, but an environmental one too.
Precisely. And then there's the data dilemma. These models need vast amounts of information to learn, and we might be running out of the high-quality data they need to keep improving.
Wait, so AI could eventually run out of data to learn from? Is that what you're saying?
It's a concern, yes. The availability of high-quality, diverse data is a bottleneck. Researchers are looking at using synthetic data. That's information created by algorithms to mimic real-world data as a potential solution.
So basically training AI on fake data. That sounds tricky. Does it even work?
It's promising, but it comes with its own set of challenges. Creating synthetic data that truly reflects the real world is hard, and there are concerns about, potential bias and whether AI trained this way will generalize well to real situations.
This is fascinating. So what happens if these mega models really have reached their limit? Are we stuck? Is this the end of AI advancement?
Not necessarily in Orion. Researchers are exploring alternatives to simply building larger models. One interesting direction is the development of smaller, more specialized models.
So instead of one giant AI trying to do it all, we could have specialized AIs that are experts in specific areas.
Exactly. These specialized models are designed to excel at specific tasks without needing the immense computing power of their larger counterparts.
Okay, give me an example of this in action. What are some of these specialized models out there?
One example is OpenAI's O1 model designed for enhanced reasoning abilities. It showed promise initially, but a study by Apple researchers suggests it might not be as advanced in abstract thinking as initially claimed. While it can produce fluent text, it struggles with certain types of logical reasoning.
So even specialized AI has its limitations. But this shift away from bigger is better. Are the big names in tech on board with this? What are they saying?
There's definitely a growing awareness of the limitations of the current approach. Bill Gates, for instance, predicted that the successor to GPT-4 would be less impressive than many expect. And Gary Marcus, a well-known AI researcher and critic, has been saying for years that we need fundamentally different approaches to achieve true artificial general intelligence.
Wow, so even Bill Gates is skeptical. That's interesting. What are these alternative approaches they're hinting at? What else is out there besides these specialized models?
Well, there are some really fascinating possibilities on the horizon. Quantum computing, for example, has the potential to revolutionize AI.
Quantum computing. That sounds super futuristic, but how would that even work with AI?
It's all about harnessing the principles of quantum mechanics to perform calculations in a radically different way than traditional computers. Imagine a computer that can explore all possible solutions to a problem simultaneously. That's the power of quantum computing.
Okay, my mind is officially blown.
Yeah.
But isn't quantum computing still a long way off?
It's true that it's still early days, but the potential is enormous. It could lead to AI models being trained in minutes or hours instead of days or weeks, and open up possibilities that are currently limited by the power of traditional computers.
So quantum computing could be a real game changer for AI.
Absolutely. But it's not the only alternative being explored. Researchers are also looking at advanced materials that could lead to more efficient and powerful hardware, and even entirely new approaches to computation.
This is getting pretty deep. It sounds like the future of AI is at a crossroads, with both challenges and exciting possibilities. So what does all this mean for us regular folks? Should we be worried about AI hitting a wall?
What's important is to understand that the rapid pace of AI advancements we've seen might not be sustainable. We might need to adjust our expectations. However, it also highlights the importance of human ingenuity and the need to explore different paths to unlock the true potential of AI.
So it's not just about making AI bigger, it's about finding the right tools and approaches to solve specific problems.
Exactly, and it also underscores the crucial role of human ingenuity in shaping the future of AI. We need to be asking the right questions, setting the right goals, and making sure that AI development aligns with human values.
I love that quality over quantity and keeping human values at the forefront. Okay, we've covered a lot of ground, but I have one more question. This article mentions that AI is facing challenges in meeting user expectations. What does that mean exactly?
It's important to remember that AI is still a young field. While we've seen remarkable progress, AI systems still struggle with tasks that require deep understanding of context, common sense reasoning, and the ability to learn and adapt to new situations.
So AI can write a sonnet that sounds like Shakespeare, but might not understand the deeper meaning behind the words?
Precisely. And it might make mistakes when faced with situations that require common sense or reasoning that humans do naturally. There's still a gap between what AI can do and what we often expect it to be capable of.
That makes sense. We've created these amazing tools, but we're still figuring out how to use them effectively and responsibly.
Exactly. And that's why conversations like this are so important. We need to understand both the limitations and the potential of AI so we can navigate this rapidly evolving landscape thoughtfully.
Well said.
Welcome back to our deep dive into the world of generative AI.
We're picking up right where we left off, exploring the potential alternatives to those massive AI models that might be hitting a plateau.
As we discussed, there is a growing realization that simply scaling up might not be the only path to achieving true artificial general intelligence.
Yeah, it's like trying to build a skyscraper by just stacking more and more bricks on top of each other. At some point, you need a different approach.
Precisely, and one of the most intriguing alternatives is the development of smaller, more specialized AI models. Think of them as specialized experts in specific domains rather than generalists trying to do it all.
Okay, I'm starting to get the picture. So instead of one giant AI brain trying to handle everything, we could have a team of smaller, more focused AI brains working together.
Precisely, each specialized model would be trained on a specific type of data and designed to excel at a particular task. This could be anything from analyzing medical images to translating languages to composing music.
So it's like having an AI doctor, an AI translator, and an AI composer all working in harmony. That sounds pretty cool.
It certainly has the potential to be, and the beauty of this approach is that these specialized models wouldn't require the same massive computing power as their larger counterparts. They could be more efficient, more cost-effective, and potentially even more accurate.
Okay, this is starting to sound like a real game changer. But how would these specialized models actually work together? Would they be communicating with each other?
That's a great question. The key challenges in developing this type of AI ecosystem is figuring out how to get these specialized models to communicate and collaborate effectively.
So it's like building a team of AI experts, but then you need to make sure they can actually work together as a team.
Exactly. Researchers are exploring various approaches to facilitate this collaboration. One idea is to create a central hub or platform that acts as a sort of AI coordinator, directing tasks to the most appropriate specialized model and integrating their responses.
Interesting. So this central hub would be like the conductor of an AI orchestra, making sure everyone is playing in sync.
That's a great analogy. And just like a conductor brings out the best in each musician, the central hub could help to leverage the unique strengths of each specialized AI model.
Okay, I'm really starting to see the potential here, but I'm also curious about the potential downsides. Are there any risks or challenges associated with this approach?
Of course, like any new technology, there are always potential challenges. One concern is that if these specialized models become too narrow in their focus, they might struggle to adapt to new situations or handle tasks that fall outside their expertise.
So it's like having a team of super specialized doctors, but if a patient comes in with a completely new or unknown condition, they might be stumped.
That's a good way to put it. Researchers are working on ways to make these specialized models more flexible and adaptable, but it's definitely an ongoing challenge.
Another concern that comes to mind is security. If we have all these different AI models working together, how do we ensure that they're secure and that their data is protected?
That's a crucial question. Security is paramount in any AI system, but it becomes even more complex when you have multiple models interacting with each other. Researchers are developing new security protocols and encryption methods specifically designed for these types of distributed AI systems.
So it's like building a fortress around each AI expert and then creating secure communication channels between them.
Exactly. It's a multi-layered approach to ensure that the entire system is robust and protected from potential threats.
Well, it sounds like there's a lot of work to be done, but the potential benefits of this specialized AI approach are huge. Are there any real-world examples of this already in action?
Absolutely. In fact, this approach is already being used in various industries. Although often on a smaller scale, for example, in healthcare, there are AI systems that specialize in analyzing medical images like X-rays and CT scans to detect abnormalities.
So these AI systems are like expert radiologists helping doctors to make more accurate diagnoses.
Precisely, they can spot subtle patterns that might be missed by the human eye, leading to earlier and more effective treatment.
That's incredible. Are there any other examples?
Another area where specialized AI is making a big impact is in financial services. There are AI systems that specialize in fraud detection, risk assessment, and even algorithmic trading.
So these AI systems are like financial whizzes, helping banks and investors to make smarter decisions.
Exactly. They can analyze vast amounts of data to identify patterns and trends that humans might miss, leading to more informed and profitable decisions.
Okay, I'm definitely seeing the value here. But let's shift gears for a moment and talk about another potential game changer in the world of AI quantum computing. I'm still a bit fuzzy on how this technology actually works.
Well, in a nutshell, quantum computing harnesses the principles of quantum mechanics to perform calculations in a completely different way than traditional computers.
Quantum mechanics? That sounds pretty complex. Can you break it down for us non-physicists?
Sure, in the quantum world, particles can exist in multiple states simultaneously, unlike in the classical world where a bit can be either a 0 or a 1. This property, known as superposition, allows quantum computers to perform multiple calculations at the same time, giving them a massive speed advantage for certain types of problems.
Okay, so it's like having a computer that can explore all possible solutions to a problem simultaneously rather than having to check them one by one.
Exactly, and this makes quantum computers particularly well suited for tasks that are currently intractable for classical computers, such as simulating complex molecules for drug discovery or breaking the encryption codes that protect our online transactions.
Whoa, that's mind-blowing. So how could quantum computing be used to advance the field of AI?
Well, one of the most promising applications is in the area of machine learning. Quantum computers could potentially speed up the training of AI models by orders of magnitude, allowing us to create more powerful and sophisticated AI systems.
So imagine being able to train an AI model in minutes or hours instead of days or weeks. That would be a huge leap forward.
Absolutely. And it could open up entirely new possibilities for AI applications that are currently limited by the computational power of classical computers.
Okay, I'm starting to get really excited about the potential of quantum computing, but I know it's still early days. What are the main challenges facing this technology?
One of the biggest challenges is building quantum computers that are stable and reliable. Quantum bits, or qubits, are extremely sensitive to their environment, making them prone to errors. Researchers are working on various techniques to improve the stability and coherence of qubits, but it's a complex engineering challenge.
So it's like trying to build a computer out of the most delicate and fragile materials imaginable.
That's a good analogy. Another challenge is developing quantum algorithms that are specifically designed to take advantage of the unique capabilities of quantum computers. Traditional algorithms often don't translate well to the quantum world, so we need new ways of thinking about computation.
It's like having a brand new super powerful tool, but we need to learn how to use it effectively.
Exactly, and that requires a whole new set of skills and expertise. Fortunately, there's a growing community of researchers and developers working on both the hardware and software aspects of quantum computing.
Well, it sounds like quantum computing is a field with enormous potential, but also with significant challenges to overcome. What's the timeline for seeing real-world applications of this technology?
It's difficult to give precise timelines as the field is evolving rapidly, but many experts believe that we'll see significant breakthroughs in the next decade or two. Some applications, such as quantum simulation for materials, science might arrive sooner, while others, such as large-scale quantum computing for AI, might take longer.
So it's a waiting game, but it's a wait that could be well worth it.
Absolutely. The potential benefits of quantum computing are simply too great to ignore it. Has the potential to revolutionize not only AI, but also fields like medicine materials, science, and cybersecurity.
Okay, so we've got specialized AI models in quantum computing, both offering exciting alternatives to the bigger is better approach. Are there any other promising avenues being explored in the quest for artificial general intelligence?
One area that's gaining increasing attention is the integration of symbolic AI with deep learning.
Okay, back up a sec. Symbolic AI, deep learning. Can you remind us what those terms mean?
Sure, symbolic AI is a traditional approach to AI that relies on explicit rules and logic to represent knowledge and solve problems. It's like programming a computer with a set of if-then statements. Deep learning, on the other hand, is a more recent approach that uses artificial neural networks to learn patterns from data. It's like training a computer to recognize images by showing it thousands of examples.
So symbolic AI is like the old school rule-based approach, while deep learning is the new kid on the block with its neural networks and data-driven learning.
Exactly, and for a long time, these two approaches were seen as separate and even competing paradigms. But in recent years, there's been a growing recognition that they might actually complement each other.
So instead of seeing them as rivals, researchers are starting to think about how they can work together.
Precisely, the idea is to leverage the strengths of both approaches to create more robust and versatile AI systems.
Okay. I'm intrigued. How would this integration actually work in practice?
One approach is to use symbolic AI to provide a higher-level understanding of the world, while deep learning handles the lower-level pattern recognition and data processing.
So it's like having a symbolic AI system that acts as a kind of manager, setting goals and making strategic decisions, while the deep learning system acts as the worker, carrying out those decisions by analyzing data and making predictions.
That's a good way to think about it. The symbolic AI system would provide the context and reasoning abilities, while the deep learning system would provide the efficiency and scalability.
This sounds like a powerful combination. Are there any real-world examples of this integration in action?
One promising example is in the field of natural language processing. Researchers are using symbolic AI to create knowledge graphs that represent the relationships between words and concepts, while deep learning is used to process and understand the nuances of human language.
So the knowledge graph provides the background knowledge and common sense, while the deep learning system handles the grammar and syntax.
Exactly. This combination allows AI systems to understand not only the literal meaning of words, but also their deeper implications and connections.
That's amazing. Are there any other examples?
Another area where this integration is showing promise is in robotics. Researchers are using symbolic AI to plan and reason about actions, while deep learning is used to control the robot's movements and interactions with the environment.
So the symbolic AI system is like the robot's brain, making decisions about what to do, while the deep learning system is like the robot's body, carrying out those actions.
Precisely, this combination allows robots to be more adaptable and intelligent, able to handle complex tasks in dynamic environments.
Well, it sounds like the integration of symbolic AI and deep learning is a really exciting avenue for AI research.
Absolutely. It has the potential to bridge the gap between the rule-based reasoning of traditional AI and the data-driven learning of modern AI, creating a new generation of more powerful and versatile AI systems.
I love how we're exploring all these different paths towards artificial general intelligence. It's like we're on a grand adventure charting the uncharted waters of AI.
Indeed, and as we've seen, there's no single solution or magic bullet. It's about combining the best of different approaches, pushing the boundaries of what's possible, and always keeping in mind the implications of our creations.
Welcome back, Deep Divers. It's time for the final part of our exploration into the future of generative AI.
We've covered a lot of ground, from those giant AI models potentially hitting a plateau to the intriguing possibilities of specialized AI quantum computing and even integrating symbolic AI with deep learning.
It's been a wild ride, for sure. But now things get even more interesting. We're going to tackle some of the biggest questions facing AI, the kind that make you really think about the future.
It's important to address these questions as AI becomes more powerful, especially when it comes to the impact on society as a whole.
Right. So let's dive in. What about this idea of job displacement? People are worried about AI taking over their jobs, and it's not like we're not already seeing it happen in some areas.
It's true that AI is automating some tasks, but it's not a simple case of AI replacing humans completely. It's more about a shift in the types of jobs that are out there.
So what you're saying is new jobs will emerge alongside the ones that are being automated.
Exactly. Think about it. AI development, data science, AI ethics. These are all fields that are booming because of AI, and they require specific skills that humans possess.
So instead of being afraid of AI taking our jobs, we should be focusing on adapting and learning these new skills for the future.
That's the key. We need to invest in education and training programs to prepare people for the AI-powered economy. It's an opportunity for growth and innovation.
I like that perspective. AI as a catalyst for a new era of work. That brings us to the broader impact of AI on society.
Yeah.
How do you see AI shaping our world in the coming years?
AI has the potential to revolutionize almost every aspect of our lives, from healthcare and education to transportation and even entertainment.
So it's not just about doing things differently, but about changing how we live, learn, and interact with the world.
Absolutely. Take healthcare, for example. AI can help diagnose diseases, discover new treatments, and provide personalized care tailored to each individual.
It's like having a personal AI doctor who knows everything about your health and can provide the best possible care.
That's the idea. AI can analyze vast amounts of data to identify patterns and insights that humans might miss, leading to better healthcare outcomes.
What about education? How can AI transform the way we learn?
Imagine a world where every student has access to personalized AI tutors. These AI tutors could adapt to each student's learning style, provide tailored lessons, and give real-time feedback.
That sounds incredible. It would be like having a teacher who truly understands your strengths and weaknesses and can help you learn in the most effective way possible.
Exactly. AI can make education more engaging, personalized, and accessible to everyone, regardless of their background or learning challenges.
And what about transportation? Self-driving cars are already making headlines. But what other changes can we expect?
AI can optimize traffic flow, make transportation systems safer and more efficient, and even create entirely new modes of transportation.
So imagine a world where traffic jams are a distant memory, where accidents are rare, and where you can get from point A to point B seamlessly and sustainably.
It's a future that's within reach. And these are just a few examples of the countless ways AI can impact our lives.
This is pretty mind-blowing. It sounds like AI has the power to solve some of humanity's biggest challenges and create a truly amazing future.
That's the potential. But it's crucial to remember that AI is a tool, and like any tool, it can be used for good or for ill.
So we need to be responsible with how we develop and use AI.
Absolutely. We need to ensure that AI is aligned with human values and that it benefits all of humanity, not just a select few.
That's a great point. It's not just about the technology itself, but about the choices we make and how we use it.
The future of AI is not predetermined. It's up to us to shape it in a way that reflects our hopes and aspirations for a better world.
Well said. This has been an incredible deep dive into the world of generative AI. We've explored its limitations, its potential, and the profound impact it's having on our lives.
It's a rapidly evolving field with countless possibilities and challenges ahead.
And that's what makes it so fascinating. Thanks for joining us on this journey. And to our listeners, keep exploring, keep asking questions, and keep pushing the boundaries of what's possible with AI. Until next time, stay curious.